Okay, fine. So, welcome back. So, we'll be starting with today's class with what is called as Pandas. Okay, so it's called as Python Pandas or whatever it may be. Okay, so what is this Pandas? So, it's an open source Python library. It's an open source Python library and it is used for providing or working with some kind of a data analysis. So to be very precise, it's a high performance data analysis tool. Okay, so it is what we call it as this is a high performance. It's a high performance data analysis tool. Okay, fine. Why this particular thing? See, you have when I speak of data, it is having so it will be very large. See, when I speak of the data means it is that means your pandas can handle a large data sets. That means huge data. So whenever I have the huge data, I can use these pandas. See, one more thing is actually it supports. See, this particular pandas it supports or it can load okay different file formats like csv dat all those things different formats of files as input that's one more plus point. Okay. Now, whenever I speak of this, when data analysis tool, if it is rigid, then say it is limited to particular application and all, then use of that particular tool becomes very difficult. So, but Pandas is more flexible. Okay, it is more flexible in using this data. So, it is a flexible tool. You can call it as a flexible tool. See, how we represent the data? See, usually what we try to do, the data is represented in the form of either rows and columns. One beauty of this pandas is it can read this data. See, rows and columns may we call it as, I think some of those they call that as tabular way or tabulated results or tabular columns and all. So the pandas can read the tabulated values. The pandas can read the tabulated values. Okay. Now, when I have this data, suppose some of the data is missing in between. Say I have a set of data that 1, 2, 3, 4, 5, 6. Some data is missing in between. So after 7, one data is missing, then we have a 9. So 8 is missing. So the pandas has the ability to work on that missing data. So what it can do, it can interpolate or something it will do and it can work on it. Okay. Then doing some operations. Okay. Some of the operations, what we told earlier, we discussed in your Python regular classes. So it can be either indexing, it can be either indexing or maybe slicing or subsetting. It can be subsetting or slicing the data. Okay. Why we have to do this actually slicing and all? Because I'm using the large data. So whenever I'm trying to use this large data, see what is it actually? Let me give an example. Say for example, I have a serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that I have an X column, I have a Y column. So I have to slice it into 3 first data and 3 last data. So 1, 2, 3 first 3 data I can slice and cut it off. The last 3 data that is 8, 9, 10 I can cut it off and do. So that's called as a slicing. Subsetting means I want to go to a particular X value, maybe third. See, whenever you have the serial number 3, go to that X value. So subsetting means I have to go to that particular point able to work on it. So indexing means where exactly I want to go. So I am referring to which number, referring to which particular X and Y column. So those things can be easily done using your pandas. Okay. And also some of the other operations, so as I told, indexing, slicing, subsetting and all, even some kind of a merging or some kind of a joining, that also can be done. That is, we call that as merging the data. So merging the data set, or it can be, I think few books simply joining. See, merging means I want to see two similar data sets, I want to merge it, or I want to join a data A with respect to join data B. That is different. So merging is different, joining is different. So joining means, so one data below that or one data above that, I want to make it a single data. So merging means you want to combine both the data into a single data. That's called merging. This data merging or this particular or joining of this data can be easily done. Okay. Now, see the domains under which this particular field or pandas is used. Okay. If you speak of uh, domains under which this pandas is used, okay, it ranges from simple. See, most of it's built with data, the finance, so maybe statistics, okay, and your experimentation, that is in scientific, we call it a scientific, you take it as, so etc. So because of this data analysis ability, it can be used. And also some books they try to tell that, see, sometimes whenever we have this large data, we have to clean it actually. What is this cleaning means? Removing the spurious data. So some data you may not need it. So pandas has been tried to use, so pandas has been used to remove that extra data or cleaning of that particular data also, it is done using this particular pandas. That's one particular thing. Okay. And one more, the key features is actually, if you look at it actually, it is not only efficient, it is fast. Okay, it is, so we can tell that it is efficient, not only efficient in doing handling the data tool, efficient and a fast tool. That's one plus point. Okay, now can it handle time series or functionality, or can it do some high performance, maybe high performance computing? Yes, it can do. Okay, maybe some kind of a, I have a large set of data, I want to reshape it. That's something like that. Operation. Integrating. So lot many operations what I told. These are some of the things what your pandas can do. And they, I think some books they call those as features of it. Some key features of this particular thing are grouping or aggregating or transforming one data, one form of data to other form. Actually, all these things can be done in a more efficient and faster manner. That is analyzing, or we can maybe as I told, it is aggregating or transforming. All these things can be done more efficiently at the same time in a much faster way. Okay, all these things are very much important when you look at it, your domains. Say you take the finance thing, large sets of data. Simple example, say most of us, some of you may be doing some kind of a trading. Okay, so we look at, so we invest somewhere or in your share market and all, then large sets of data is used. Okay, so how the share performance, how we did it do yesterday, how it is doing now, how it's going to do in the future, so predictions. So lot many, or these are the data what we have. So your pandas can be used effectively over there. Okay. Now, so when your Python, when you want to use your pandas, you have to install it, because in Python it's a package actually. It's a package. So if you want to install it, as I told, if you are using the Windows platform or terminal, whatever it means, just go, and if you use the pip is installed, you can just go and use pip install pandas, it gets installed. Okay, or if you're using a Windows, we have three format. One is either you can go with Anaconda format or Canopy format. Okay, you can just go there and do it Windows. But Linux, you have all the, you are either you have to go with the any of these, if you are an Ubuntu user or a Fedora or any kind of Linux user, just you have to go and sudo apt install Python NumPy with SciPy, Python NumPy or Python SciPy or Python SymPy, that is symbolic mathematics, Matplotlib, Python hyphen Pandas. That's how you have to install. So Windows, you can just go to the particular website actually. So you can just click on Python, maybe Pandas installation. You'll get some kind of exe file. You can do that. Or from the terminal, you can go with pip command. Pip install Python. Okay. Now, coming to this Pandas, or what is it actually? So when we speak of Pandas, how is my data structure? Okay. If you speak of the data structure using Pandas, okay, how it is. So you maybe if you go maybe if you go by hierarchy wise, the level wise actually, if you do it, the first thing that comes to our mind is the series. Okay, the first thing that comes to our mind is series. What is this series? It is a one-dimensional data. One-dimensional data. If you go back and see, it is always in the form of a list. What is list? Within your square bracket, you are trying to give the data. That means the data you are trying to give is in the form of one dimensional thing, that is a list. Okay. Now, the second level is actually is your what we call it as data frame. So the second level is your what we call it is called as data frame. So your data frame is actually it is a two-dimensional one. Okay. Now, when I speak of two-dimensional one, I can give in the form of either a list or a dictionary. So dictionary is one kind of a this thing, or it can be one more two series. It can be series one and series two. Two series can be a two dimensions. So one dimension of series, another dimension. So I can give two dimension. That is two lists I can give. Okay. Then the third one is we call it as it is the a panel which is multi-dimensional. It is multi-dimensional. Okay. Now, whenever we try to use this particular, these data structures are built on, see how these particular things are built. See, it's more of things like I should have a NumPy. See, that's why I took the NumPy. All the data structures, you have to always remember this. It is not straight away comes from Python. All the data structures are built on NumPy. Okay, the data structures are built on NumPy. Data structures, data structures are built on NumPy. Okay, the data structures are built on NumPy. 1 minute, I'm getting a call. Okay, fine. So I'm back actually. Uh, I was telling about this series, data frame, and this thing. So your data structures are built on what we call it as a NumPy. Okay. So what is this actually? NumPy means I can call it as an array. So NumPy is an array. So when I speak of because of this particular array only, the process is getting faster. It is faster. I am able to analyze it. Okay. Now, see, when I speak of multi-dimensional, don't think there is three dimensions. It's a 3D. It's a three-dimensional. So very rarely we'll have four-dimensional. So three-dimensional labeled means it's more of like rows and columns. That's the meaning of it. Okay. Now, what is the series data? Okay. What is the series data? See, when I speak of a series data, how it is? Okay. When I speak of the series data, so yeah. Okay, there is some net connection problem. Okay. So what is the series? Series data means, uh, say for example, uh, there is a person. So maybe there are set of people. Say I'm going to give the age of them. So age maybe 10, 15, 20, 25, 30, 35. So like this. So this is a series. A series is a one-dimensional array. So it is a homogeneous data. It is a homogeneous data. Okay, it's a collection. See, what is this? If you closely look at it, most of the times they are all integers. Very rarely there will be a float or something where it will be 30.5 or whatever. Majority of the times they will be integers. Okay, and the second one is your data frame. Okay. Now, when I speak of data frame, as I told, they are of two-dimensional. So when I speak of two-dimensional, it is of heterogeneous data. Heterogeneous data. Okay. So now, say for example, I can give some kind of a data. So what data I can give? Maybe in our department itself. So name of the student, okay, or name of the faculty of whatever it may be, name of the faculty, okay, is maybe gender, age, okay, some specialization, okay, maybe some kind of a okay specialization or what subjects he's been teaching. All those things I can give that. I can give some kind of a data. I can create it actually. So X, Y, this column. Okay. This is something, but it's a table. It's a representation of a table. This table represents the data of that particular thing. So each column represents a particular, see each column, what this column represent a particular, we call it as an attribute. So name is a particular attribute. What is each row? Each particular row, that particular person. So each row, so if I take a person A, so what is his gender? What is his age? What is his specialization? If I go with a column, So I will have n number of people, A, B, C, or D, all the four names. What are I giving? Each particular column represents an attribute. Each row represents that particular, what is that particular thing? We call it as that particular thing. Maybe it represents that particular person's maybe ability or whatever. Okay. Now this is called as say data type of maybe if I have a single column, we can have two columns. Okay, or the same thing I can represent in the four column. What is it actually? See, what will be the type actually? If suppose if I try to represent the same thing in the form of multi-dimension, so then what I'm going to do is actually I'm going to use what is called as see this name itself of what data type. The name is of what type are usually names are of string type. So names is the name, it's a string. So age actually, if I try to say, if I try to go with an age is usually the data type is of integer. Okay. Once again, the gender, if I take the data type is actually once again it is an integer. So specialization, if I take, or what is the specialization? I may get once again a string. It is maybe manufacturing engineering or maybe thermal engineering or a design engineering, something like that. Or if you want to give some kind of his maybe his rating, maybe if he has got some CGPA of his master's degree or something while entering. So if I take some CGPA of that particular person at the time of interview or something, so it becomes actually a float type of data type. Okay. Now, so each thing has some kind of a data type. So now what is the difference between, see, this is your data frame, a data frame with the data type. Okay. A data, see, what is this particular, what I'm speaking of is a panel. It is a data frame with the data type. With the type of data, it is called as a panel. See, it is once again heterogeneous data. See, data frame itself is an heterogeneous data, whatever, because it's not having a single this thing. So, panel is a what I call panel is a three-dimensional data or a multi-dimensional data. It is an heterogeneous data with the type of data. It's a heterogeneous data with the type or data type, and this is called as a panel. Okay, now you got an area. So now, if I want to invoke this particular either in pandas, what I should do in your program, how your syntax should be. The syntax for this particular data frame or series and all, how it is actually. Syntax, how it is actually. The first thing I have to do is actually, it is import pandas as it can be anything PD or PDN, whatever you can do. Usually default majority of them they go with PD. Okay, it's not PD dot, it is just PD. So import pandas as PD, import numpy as NPC, because this pandas most of the time it comes under numpy. So you have to import that numpy as well as import the pandas. Now how I can define your series? The syntax for that particular thing is actually it is P dot. Look at this. The S should be always a capital. If I try to put a small s, actually it gives an error. So S is a capital. So it goes with the default syntax is data and index. Okay. Now if I want to invoke the data from, it is PD dot capital D, that is data frame. Okay, it is simply a data, whatever I am going to do it. Now, how is your panel? It is PD dot capital P. It's a panel. It's a multi-column. Okay, so in this data, you have what is called as a major axis, a minor axis. Okay, and then data type. So this is how the syntax will go. Okay. Now, if you look at the majority of this particular thing, majority of your pandas, this is the one which is extensively used. So data frames are extensively used. So in maybe in most of your applications. Okay. So now here also sometimes very rarely they use in series also there's sometimes they use data type, but if you use the data type automatically it becomes your pan. Okay. Now say I want to do this. So the first and foremost thing how you have to do it is importing your pandas library, aliasing as PD or PDM or whatever it may be, then define that A or B or C or is equal to PD dot series, define that, then print that particular thing, you will get this thing. Suppose if there is a numpy is there, if there is a numpy is there, how I have to do? If there is a numpy, I have to do it actually. If there is a numpy, I need to do it. In that case, so it will be something like this. The syntax will be something like this. Let me call it as some example. Okay, let me call it how we are going to do actually. We will try to import pandas as PD. Okay, import numpy as np. Okay, now once you have defined this, so let me call it as some kind of a or data or whatever it may be. A is equal to np dot array. I want to create an array, let it be some A, B, C, D or whatever it may be. Strings, let me define it. A, B, C and D. I defined it. Now if I want to define this particular thing, let me call it as B. B is equal to PD dot series of A, and if you want you can print B. So then what will be your output? If you look at your output, how it will be actually, your output will be something like this. Your output will be, what it will be? 0, 1, 2, 3. It will be A, B, C, D. So this will be your output. Okay, what is object type, data type actually? It's an object actually. It's an object type data. Okay, now if suppose if I try to give an index to it. So default index is 0, 1, 2, 3. As I told, see here what I have done is here default index I am getting. See default index is 0, 1, 2, 3. So instead of that actually I have to define my own index. So what I am going to do, I will just replace this thing by I will write it as B is equal to, let me define some 100, 101, 102, 103, 104. Let me define something like that. So PD dot series, okay, it is your data, that is your A, comma, index is equal to, so within your square bracket, let me call it as 101, 102, 103, 104, 4 data is there, and close the square bracket and close the brace. Then what is going to happen in that case? Your output will be, for this particular case, your output will be 101 A, 102 B, 103 C, 104 D. Then your data type is once again the object actually. Suppose if I want to create a dictionary, I can do that. See, it all depends on what you are trying to do, whether you are trying to do with the list or you are trying to do with your corresponding list or your whatever the data you are trying to do it. Indexing means I'm going to define that index as what I want. So 1, 2, 3, 4. Default is 0, 1, 2, 3. Or I can change it. Okay. Now, so when we try to speak of this series, Series means I'm going to have a single or one-dimensional thing. So maybe if I go with respect to a data frame, okay, the next thing is how the syntax for the data. Data frame, as I told, it's a two-dimensional structure. Okay, data frame is a two-dimensional structure. So now, say for example, let's assume some data what we have. So let's take your students' thing. Let me go with what we have. So data frame. Okay, so data frame. Yeah, I think I forgot to tell you. So when you are defining data frame, so this should be capital F. I forgot. This should be capital F. Sorry, DATE capital, F is also capital. Yeah, it should become. So data frame. So how we can define it? Let's take an example actually. What example we can give? So data frame. Let me give your own example. Say you have your USN number. Fine. You have your university seat number. Then you have your name and maybe percentage marks or whatever the marks you have scored. Let me define that itself. Percentage marks. Okay. So let me go with that. What are this may be your data, what we have. So this is how your data is there. So let the register USN number be. Let me start some number. Let me put it as some 1000, 1001, 1002, 1003, 1004. So I'm just giving some default number. So let me give some name as Arun, Anup, Bipin, okay, then Chirag and some Daniel. Some names I'm given default. So percentage of marks scored actually. Let me give this as some 86.5% and he is scoring around 92.5. This guy is scoring around 75 point some 2. So he is scoring around 68.5. So he is scoring around 82. Some default, some percentage I am given. Now, what is this actually? See, these are, see, what are these actually? These are rows. Okay, and these are my columns. Agree? So I have the set of rows and set of columns. Okay, and few books they call this as mutable. Size is mutable. Potential columns are different types or whatever. There are different data types. See, what are the different data types? What we have? If you look at it, we have different data types. So USN number can be an integer. Name is once again your maybe string. Percentage is a float. So you have a different data types. Okay. Now, when I speak of data types, so it's something like data frames, we have different things. I can use a list, I can use a dictionary, I can use series, I can have the numpy arrays itself, I can have a data frame, or maybe I might have created a data frame in my previous problem. That data frame itself, I can use it as a data, maybe a data for the existing one. Okay. So now, if you want to use this particular syntax for writing a program for this, how I can do it actually? Now, as I told, what should I use actually? Here, the first thing is you have to import pandas as PD. Okay. Then, maybe whatever the data frame DF or DG or whatever it may be is equal to PD dot data frame that particular data. And what is the data I am trying to give? So data is what you are trying to give. So you are trying to give in the form of maybe USN number, name, a percentage of marks, or you are using the name, age, or rank. Anything you can give. Anything you can give as a data. So that data can be visualized it. Okay, that data can be visualized. So how it can be? Let me write a simple code for this. So data is example. This is some example 2. So how it is syntax is something like import pandas as PD. Okay. Now let me call this as some data what we are trying to give. Okay. Data means, so what we have actually, we have let me call data is equal to, so we have a dictionary kind of a thing. The first is USN number, it is under colon. So what are the things we have? We have Arun, okay, then we have Anup. So I will write three data. I don't want Anup. Then Bivin. So same thing can be done. So Bivin. So three data I have closed. Okay, comma, then name. Okay, then name. Sorry, this is USN number. Sorry, I should have used the name here. So this is name. Should have gone there. So here USN number is 1000, 1001, and 1002. So name I should have used Arun, Anup, and Bivin. I am continuing this one. Okay. Now what is the next thing I need to use actually? Comma, your marks. Okay. Let me give the call that as marks. Percentage marks actually. I am calling that as maybe I'll give 86.5, 92.5. So 86.5, 92.5 and 75.2 and 72.2. I define that. Okay, then close it. Sorry, I have to close the flower bracket. I close this particular data whatever. Now if I want to define this as a data frame, what should I do actually? I will, let me call it data frame as D1 or D2, DF1 or whatever it may be. Let me call it term DF1, okay, is equal to PD dot, here you have to be very careful. Data, this F also should be capital. So D should be capital. Let me underline that. D should be capital, F should be capital. Data frame of, if I give simply the data, it will automatically index will be 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4, and you will get all the input. So age or name, whatever you are going to give, that will come as an output. Suppose if you want index, you can give the index. So index I can give whatever I want. So index can be serial number 1, 2, 3, 4. Or serial number you want it to be some kind of something like student number 1, student number 2, what you want you can define. So either this can be thing or you can give an index whatever you want. You can index and you can get it. So what will be your output actually? So once you try to print df1, what I'm going to get actually, your output, I'm going to get your index output here. Okay, then I'm going to get your USN number, then I'm going to get the name, okay, then I'm going to get the marks. So index parameter, whatever though, is assigns the, if it is defined, it will take those values. If it is not defined, it will go with the default values as 0, 1, 2, 3. Okay. Now, is it possible for us to define dictionaries in your per data frame? Yes, it can be done. So let me give. So this is what I'm showing is a list actually. Suppose if I want to define a dictionary, okay, data frame from list of dictionaries. So dictionary. So data frame. I think after this we'll try to stop. So a data frame using dictionaries. Already we know how to define a dictionary. So if I want to do that, example is something like import pandas as PD. Okay. Now data is equal to, let me define that. Okay, let me call this as, so within your bracket whatever we have, so it is A, let me call it as some 10. Okay, A is equal to some 10. Okay, then let me call some B, okay, is equal to some 20. Okay, I have two data. Then I can give one more the dictionary. A is equal to some 5. Okay, then B is equal to maybe some other sum 15. Okay, then if you want, I can have C, D, or whatever it may be. So C also I can define. So C, if you want, I can define C. You can identify that. You can see that in this particular thing I have not defined C, but in the second one I have defined C. So C has some 25. So C has some 25. I closed it. So this is a dictionary. What I have defined, it is a dictionary. I define this as a dictionary. Now, if I want to get the printout of it, actually it will be data of df1 or df2 is equal to, it is pd dot data frame of the data. I'll just go with the default indexing. So print df2. If I do that, what will be your output actually? Your output will be something like index. What is the default index? Default index will be 0 and 1. Okay, then under A actually, so under A, what I am getting actually, it is 10. Okay, under B, I am getting 20. See, under C, I have to get no output, so I have to get some null. So the output will be nan or something. So under C, under A, for the second thing, I am going to get 5. It is 15 and 25. This is how you're going to define your thing. Maybe some of the I've seen some of the computers, so they try to give 10.0, 20.0, 5.0, 15.0, 24. It automatically gets converted to float as an output, even though I'm defining as an integer at the input level, but it takes as an output as a float actually. So few computers have seen all the things will come as an integer, and few, see, it's nothing but, see, nan means it's a not a number, or I have not defined it actually, or missing number or whatever it may be. Or few books they go with what is called as a simple, the few laptops or your system computers, they give that as a integer itself. So this is how your pandas are defined actually. So pandas